So the first good example is a baseball radar gun. And the way it works, you'll notice the guy with the radar gun, he actually gets level to where the ball is going to be. He doesn't use the radar gun up here when the ball is traveling down here. Okay? Now a cop is much easier because the cop radar detector, the vehicle is so large that it can automatically find whether it's, the radar guns up here or down here. It's going to find it either way. Now, another application of this is where this really came from are bats. Bats travel using sonar waves. That's why, when you see, at night, the bats are flying around, you hear them, squeaking. They're sending out sonar waves, and based on the time it takes to get back, they have a good idea of how the area, or, say, the house might be shaped. So even in the dark, bats will be flying. They use sonar to indicate where objects are. Now, I like the description that you both gentlemen gave, that the idea is, you send a wave and it comes back after a certain amount of time. So underwater we call it sonar. It's called sonar. What's it called for in the air with aircrafts? Radar. Radar. Good, radar. And radar you'll see, ever see on movies, you see the radar goes in the circles, beep, and you see the object moving further and further out. It's constantly sending out a pulse, and that pulse is being returned. Now, when we get to electromagnetism later in the year, we're going to talk about things like the speed of light. Well, the wave that it's sending out travels so fast that it's able to keep up with it. So it's able to detect how fast the object is moving. Imagine though, if I wanted to know how far the door was, and I threw a ball against it, and the ball came back, and I judged how long it took the ball to come back to show me how far away it is. That would be fine for the door, but what happens when I want to find out how far across the street that building is?
I can make it.
Right? I got to throw a tennis ball that can really shoot back pretty fast, right? Or it can make it all the way there and all the way back. So the idea of radar, using sound waves and using light waves and just EM waves in general, helps us indicate, the distance an object may be. Okay? Now, what we're going to do today is the following. This here is exactly what we're talking about. All it is a simple detector, and it detects how far away something is by sending a pulse and receiving a pulse. Now, it works better when we stack it on something. So I'm going to grab a few textbooks because, and I'll explain why this works, and maybe somebody else can figure this out. If I left it where it is now, and I were walking back and forth, and I wanted this to detect where I am, what might the issues be if I left it where it is? If I leave it where it is now, why might it not look too well? Hold on. Focus. The difference between here and here, I'm saying. Why is it better to have it up here than down here?
Because if it's down there, then up here it's higher up, so it can catch more of your body.
Yeah, good. If the radar detector is higher up, it'll shoot the radar wave into my chest. Versus right now, if it shoots a radar wave and I'm walking, it might go past through my legs, right? But if I put the radar detector up here, it'll work much better. These are things you need to consider when you're doing experiments, right? Why doesn't stuff work? Why isn't your data reasonable? Well, there's a mistake, or there's some sort of glitch. Thank you. That's the word I was looking for. There's a glitch in the system. Okay? All right. Now, there are two settings on here. One shows a person. One shows like a cart or a vehicle. Later in the year, we're going to use these carts and we're going to work with them on ramps. And we're going to detect the motion of those. And you're going to be able to work on those on your own. For today, we're going to do a demo, or we're going to do a lab, and I'm going to have you guys come up. So what I'm going to put it on, I'm going to put the indicator on a human being so we know that it's on a person. Okay? Now, once I hit start, you're going to see a little thing start to appear, and it's going to start to track where the object is. Okay?
So it's only tracking the joke.
So for now, yeah, it would shoot away somewhere back here. It wouldn't work very well. So what I'm going to ask is for you guys to move over.
Yeah, Joey doesn't get sensed a lot.
Just slide over a little bit. You want to do the first one? Okay. Jacket will talk. Two different colors might throw it off. Believe it or not.
Where's Joey?
Okay. Slide your back in.
Joey looked good.
Alright, start. Next. Start over here. Now, everybody, what are the units under position? What do you see in parentheses? Meters. So, we have a ruler in the room. We do have a ruler right here. Okay. So, if I wanted to find 1 meter, I'm not going to touch it. This is about, let's say, this is 30 centimeters, 60, 90, here's about a meter right here. So Max, stand right here for a minute. Okay? So Max is about a meter away. Now, with all of these devices, there's something called a dead zone. Relax, Paul, I know.
I'm excited. I just want to do
So, there's a dead zone. And the dead zone, all it means is this. If you get too close to the device, it stops reading where you are. So anything within, like, I think it's like a half of a foot or so, anything within here, it's going to show up as if you're right against the device and you're at 0. So Max is approximately 1 meter away, approximately. So when I start this, what we should see, hopefully, is a bunch of dots appear at the 1 meter mark, because that's his position. But what will happen as he moves away? What's going to happen in position? And as he gets closer,
lower.
okay, until he gets up against it, then where will it be?
You're gonna get in there.
Okay, when he gets up against it, it should be 0. So Max, you're going to stay there for a second, right? Let me start this, okay? So, what do we notice? Where is it reading Max to be? I'm going to pause it.
1.4.
Okay? So I stopped it there. So Max was around 1.4 meters. So there's a good chance, no, it's not, the machine just might be calibrated off. It's not a big deal. There's a good chance that, then again, I was estimating the distances there too, don't forget. So what I want you to notice next is, what I want you to do, Max, back up a little bit now.
I did a little further.
So go even further. Good amount back. Like another 2 or 3 steps. Like real steps. There you go, okay. Now, maybe a little bit further out. Just a little bit. Good, right there. All right, so let's see what it reads now. Okay, so now let's see what it reads. Take a look. So now Max is approximately a quarter meter away. So you get the idea so far, right? Easy enough. Now what I want you to do is start to walk away. Now stop. What happens when it stops? And notice, it's only turning around there. Because when you turn your body, it indicates that you got closer. Let's talk about this. That's actually, I like the this right here. See this little glitch right here? What happened there was this. Max went all the way here. As he turned around, watch what happens. This part of my body gets closer, doesn't it?
Oh, yeah.
That's where that little dip is there. Then he turned around again, and that part of the body got further. So you saw this little dip right here, because he got closer, and then when he needed the full, guys, we need to focus, come on. When he needed the full rotation, he went back to where it was. Then you saw him kind of like do a little dance, or whatever that was called there, and then he got a little bit closer there at the end, okay? All right, so, what I want somebody else to do, thank you, Max, well done.
Well done, Max.
Okay.
Everybody gets one.
What I would like somebody else to do, I gotta clear this ink, man, I don't get rid of this.
You can
All right.
Please.
I need 2 people, 2 people. Let's do a boy and a girl, please.
Me and Molly.
Huh?
Me and
Molly's a girl?
And Jack.
Jack? All right, come on up, Jack.
Oh, God. We don't get the motion.
All right, so here's your challenge. I need one person that's going to be the mover, the other person that's going to be the grapher. The grapher part's a little tougher than looks, not just
I'm
so.
a mover.
All right. No. So Molly, what you're going to do is this. There's a function on here. It's a little pencil. See this? Molly can draw a graph. So Molly's going to come up with a graph. Jack, you can't look. Okay? So Jack can't look. Molly's going to draw a graph. Then we're going to give you about 10 seconds to look, Jack, and you have to try and mimic the graph. Does that make sense?
Yes.
So she's going to put up a graph that pre-exists. Your motion has to mimic that graph. Okay? So Molly, it's tough to use this, unfortunately, and you can't use the smart board. I wish you
My
could.
finger?
You have to actually use the mouse pad,
Oh, okay.
and it goes very slowly. So if you hold it down, it's going to look like this. See how I'm doing this?
Okay,
You hold
yeah.
down, and then you can move. And I'm going to
Okay.
clear this,
All right.
just so you can see.
And where should I start from? Right here?
How do I get rid of it?
I guess we predict how
You,
far
yeah,
away he is.
so he has no. You have to start wherever you want, and he has to fit it according to that.
Okay.
How do I get rid of this? There we go. Okay, so you're gonna have the option of do. Now, you can do straight line, then like a slanted, then a slanted down to make it easy. You can curve it to make it harder. It's up to you.
Okay.
So again, to look at it for like 10 seconds, get an idea of what's going on, and then try to mimic what she actually drew. Now, Molly, don't go too far away. Keep going, but don't go too far away because she's only got about 3 meters of clearance.
Okay.
So don't go above 3 meters.
I go.
Okay, you're gonna have to go keep further. Now, when you do this, what you want to do while you're doing it, you might want to face the board as you go so you can see. Yeah, that's fine. Okay? All right, cool.
Is that good?
That's fine. That looks great. So, Jack, you're allowed to look now. So, Jack, you're going to start somewhere here, and then you have to follow this path for the time. Now, look at the time. She went from 0 to 7 seconds. So, your whole motion needs to take 7 seconds. Think about how long you have to do this for, and how long you have to do that for, and so forth.
And I can watch.
You can watch as you're going. Now, keep in mind, this is 1.8 meters here. That's your starting point. So, I might think that you might want to back up a little bit. Sorry, 1.4. Thank you, Molly.
Back up a little.
Okay? So Molly's going to hit start. When she hits start, you got to go. And try and
No pressure, Jack. You got this.
Start?
All right. Not bad. Now, let's talk about something. Let's talk about something. We're human beings, right? So we take time to react, whereas a computer system is instantaneous, right? It has, not literally instantaneous, but it has what's called the feedback mechanism that enables it to go at a much faster rate or process information. So what I noticed right away as an engineer, I think of, Jack, you were a phase lag of about a second behind. You notice that? Look at the graphs. It started off close, then he went up as this went up, then he went down, then he went back up, and you'll notice that it's a little bit shifted. It's off. That's what we call in engineering a phase lag. So what you did was you tried to react, but human capabilities are not necessarily enough to get you to react that quick. Does that make sense? Okay? All right, another group, and we're going to do something different. Very good, guys. Thank you. Remember, this is all about position versus time. That's the graph we're looking at today, right now. Okay? Other people. Who else wants to try? Olivier, Garrett, and then Jack and Paul go next. Okay. So. You're going to do. That's all I'm going to do. We're going to go back to normal. But what you're going to do is, you have to tell me what you're going to do ahead of time. So the graph and the thing. So tell me what you're doing. In words, describe to him in front of the class what you're doing. Then Gary needs to take what you tell him, draw a graph, and you need to actually do it. Everybody hear this carefully. So Olivier is going to tell Garrett what he's going to do. Gary needs to draw that on the graph, and then he's going to do it, and we're going to see how it works.
All right.
Okay, so to the class, and that's what you do. He's going to tell you right now. So he's starting right here, and tell him what you're doing. Okay? So, one more time. He's going step forward, step back, another step back, and then a short step forward. Okay? Forward, back, backward, forward.
So we're doing draw.
You can draw what he's telling you. That's fine. I want to draw what he's telling you to make it more realistic, and then he'll do it. So you can't use that, unfortunately. It doesn't. I don't know why it doesn't work. So if I hit this right here, actually, you know what? You might be able to do that. Yeah, you might be able to. Just don't pick up the pen. Try and use your finger. So tell me what you're going to do again. Where are you starting here? It's probably like a meter, man. Yeah, it's very good. Okay, remember, start at 0 times. Okay. So what you do. See, use the mouse pads. That's what I thought was going to happen. So, hover over where you want to start.
Okay, I'm here.
Select the pencil again. Let's try it again.
Go.
Okay, hover over where you want to begin. And then hold down the left trigger and then just use the mouse pad.
Okay.
Don't let go of that trigger.
If you just put something in that box, that's not
try to do that. And if you pick up the pen, you pick it up, it starts writing on the board. It doesn't actually work that way. I'll try that.
What?
It might work. 3 seconds, hold it down.
Do something. Do one more thing. Big leap forward. Okay. All right.
Okay, so what you're going to do is you're going to hit start at the same time as he starts moving.
No, you went
So scroll, you're going to hit it further up.
forward. You went forward, back, forward, forward.
This is backwards. This is backwards. This is backwards.
No, down is forward.
This means you're going to get closer to the lights, further, closer. So you're going to hit start but synchronize with each other. Notice, we did it for a total of 4 seconds. So,
you have to like.
prep yourself right now. Just practice.
Wait, There's 4 sets. So do it. Yeah, do it each minute second.
Okay, try again.
1, 2, 3.
I think you can do like 1, 2, 3.
And
You can do it for
Yeah.
Good. All right. So, synchronize it so you know. 3 steps.
Go.
Let's go. Close. Very close. Good. Now, what would acceleration look like, guys? So, he's standing still right now. See him standing still? When he moves slowly at a steady pace, so come closer. Okay, come all the way closer. Now, walk that way at a steady pace. When he walks at a steady pace, you see there's like a slope, and the slope is pretty constant, right? Remember, the slope is the velocity? But now, Olivia, come back to the beginning, fast. Much higher slope, isn't it? See how negative that slope is? You see how much higher this slope is now? And now come back to the beginning, and almost as if you're going to run to Joey. Start to run, but stop at the table. Okay? See how that kind of curves? That's the acceleration you're seeing there.
That's how I draw my name.
Well done, guys. Now, if we go back to the beginning and maybe can we zoom in on this scene? No, I can't zoom in. All right, what you're going to notice the following. The first thing. Can I zoom in? There's got to be a way. Oh, yeah, here it is.
Oh, no, there's a magnifying glass to the left of that. 2 to the left.
I got it. Hold on. It's going to zoom select. It zooms on what I'm selecting.
Oh, got it.
So, this was the prediction right here. See the yellow line? Or the yellow three piecewise functions? Piecewise. Negative slope, positive slope, negative slope.
It's our off day today.
Piecewise continuous functions.
It's our off day.
Anyway, so it looked like he started right on par. He was good to go, right? Then the prediction didn't go back as far as, or didn't get as close as he did. So he got on the prediction as close as 1 meter, but Olivia got as close as almost a half a meter. Then Olivia went up and got caught up, but he went a little bit too far back, and then he came back down and got caught up. Okay, and then this was standing still again here, standing still, then getting much closer to the device very quickly. And that was when I walked in front of it. Notice, there was like a jump in the graph there. He was standing here, and I walked right in front. So the sensor didn't know who to read, and it jumped down, then it jumped back up to where he was. Okay? So this region right here was when I walked in front and disturbed the sensor. And in that time period, Olivier went from here to here because he also walked a little bit closer. Okay? All right, next two. Gentlemen, next two.
Can't get up. It's still gonna be 2 balls left. Oh, do high kicks.
Wait, that's me. Don't you know one long closer?
My mom said that.
Why aren't these coming off here? All right, we're back. Sorry. Let's zoom in. Okay? What do you guys want to do? Okay, well, what do you want to do? How are you going to, is one person going to predict? Is he gonna, you have to try and follow his? You want him to draw and you have to try and mimic it?
Yeah.
All right? So again, notice so far, guys, notice, when we look at the position versus time graph, we said the slope, I want to write this kind of stuff down, the slope of that graph is the velocity. You got to press the pen. Good. Okay. Then you're going to start, make sure you're starting at time equals 0, which is on this y-axis right here.
Okay.
Okay, and start at some position, whatever, however far away he's going. All right, again, the slope.
Paul, centimeter away.
The slope of the position versus time graph is your velocity. Remember that. The slope of any of these graphs around here, we'll show in a minute, we can calculate one of them, is going to be your velocity. After this, we'll go on to see what happens when we put this as velocity instead of a position graph. We'll look at a velocity graph next. So it looks to me like he's going to have a negative slope, so he's going to get closer to the monitor. Then he's got a very high positive slope, so he's going to run away from the monitor. Then he's going to come back to the monitor and go away. Looks like Jeremy wants to see Paul run around in circles. Want to make him stand still for a little at some point? Alright, he's going to be good.
Do a flip.
Alright, hover over the start. Don't hit it yet. Just hover over so you're ready. Alright, Jack, take a look. Paul, take a look for it. Get an idea of what you're going to do. Good luck. Give me another book. It's too tall.
Paul, you're
Put another table on it. What if I like
He's good. He's good.
Be quiet. We're doing our
Take a
stuff.
look. Did you know what you're doing?
Yeah.
Sure.
Yeah.
Okay.
Paul,
you guys calibrate.
Paul, do you actually know?
What?
Do you actually know?
He's just gonna thrust in really.
Do you know? Are you serious?
That's like one step for him.
Okay, 1, 2, 3, go.
Nailed it.
Let's try it again. Let's try it again.
He's too uncoordinated. He's too uncoordinated.
Well, not even as important. You need to span longer time periods. You need to span longer time
Should I
periods.
erase it then?
So let's try erasing it. Okay. Right click on the prediction. This mouse is very slow. Right click on the red line. Hit remove selected data. Go down. Remove selected data. Yes. Okay. Right click on. Actually, go to experiment. Up top. Okay. Hit delete. Hit it again. Delete last run. Remove or okay. Yes. All right. Now use the pen again. Here's what I want you to do this time, though. Give him like 3 or 4 seconds long. So like, look. Go from like here to here, like that.
Yeah.
Then go flat, maybe, then down, then up, go long, okay? Try this one more time, guys. Try it.
Think you're better than me?
Think you're push. Hey Max, Max, can you take a seat? Stomp the yard over here.
Whoa.
All right, you got a long way to go here. 25 seconds with Paul. Let's see it. You're gonna have to start when he's ready. You're ready.
Paul, do you know what to
We
do?
have to start really close, Paul.
No.
Okay.
Starting on the origin, pretty much. You hover over the start button. Oh, remember, you have 5 seconds to get back to here. So this is much slower motion this time.
Ready?
Yeah. Let's go.
1, 2, 3. Oh, whoops.
Oh my God.
David, check.
Just try to get when you're ready.
1, 2, 3.
Oh.
Now you gotta run, Paul. Paul, run back.
Fast forward. Back.
Oh, that.
Travis, that one. That was good.
Okay, now, here's what let's see. Who can get better than Paul just did? Same exact graph. Let's see who can do better.
Cammy.
You want to try?
We're all for Cammy.
Who hasn't gone yet that wants to try?
I said,
Joey? All right, Joey's going this time. All right, sit down, Paul. Thank you.
wait, did you hear what? I'll let you get
Okay. Ready, Joey? So I'm going to have to restart the time. If I can do that.
And like, he wrote like as the kind of like memories. And Katie wrote to Lucas,
Enough about Facebook and that crap. I don't want to hear it. Hold on, you don't have to go anywhere. Just stay still for a sec. Okay. It's gonna work. All right. No, it's not you. It was me. Okay. All right. You guys are the judge. Let's see if he does better than Paul did this time. He's starting in Georgian. Ready? Stand. Go. Very nice. That's a really good start, isn't it? Yeah. All right. Anybody else want to try this one? This graph, particularly.
yeah, Tyson. Yeah.
No, man, I
All right, let's go to velocity. Wait,
is this our lab or are we
there's a write-up for the lab. You'll see it. It's not hard, guys. You're going to just be getting me graphs of what things look like after doing this. So, like, phenomenon moves away, then back to the sensor, what would it look like?
Are you giving us a sensor and we bring it home?
There's one sensor, so.
So I'll take it, yeah. Everybody in my place. What?
Sensor party at
I call this one.
Okay. Now, second thing, and you're going to see these graphs, you're going to be your second ones in your lab. Velocity versus time. Somebody tell me how this is going to be different from the position versus time graphs. What's going to happen? Yeah. So for example, if I start by standing here, I'm about 2 meters away. Well, what's it going to register as on a velocity graph? Zero, because I'm not moving. Again, if I'm standing still, it should register as 0. Then if I start moving, it should register as whatever the velocity is. So let's get a volunteer to come up and see what this looks like. You don't have any requirement. We're just going to do a little demo of anything. You don't have to do a prediction this time. Come on, somebody has to come up there. All you got to do is walk back and forth. You don't do anything besides walk back and forth. All right, Cammy. All right, here we go. So all Cammy's going to do, she's going to start there, stay at rest for a little while, stay at rest, then you move back a little bit, stop for a little bit, then move forward for a little bit. Okay, but I want you to be very deliberate with your movements. So stand still, walk slowly back, stop, wait, stand still, and then come back forward. Prediction before she goes, because she's going to stand still, go backwards slowly, she's not going to fall, that's mean. Then she's going to stop and stand still, right? You got a rough crowd here. Then she's going to walk back toward the sensor. What might the graph look like for this before she does it? velocity. Very good. That's going to be above.
Once it gives it to sinister minutes to shape.
Guys, come on.
Walk back, then go up again, and then back down, which is
Okay, very good. Let's go through this. So again, depending on our direction of motion, we'll see negative versus positive quadrants. Ready?
Where's
Let's hold up. Let's try this again. You know what we got to do? Who knows what we got to do to make this look better? What happens? Not even go faster. What if I instead go from like 0 to 10 here, right?
Jump.
See how it's going from 0 to 50? It's too big of a range. So let me change these axes. Hold on.
Oh, I see.
Let's do.
Once it gets to sinister minutes to shade, then it makes a I'll wake up in the morning. I can actually read
I want to move over though. Hold on. Let's see what happens if I do this now. Okay. All right. Let's try it again. Just as a demo again. Cam, you ready?
Faster,
All right.
Cammy.
It's not picking up the velocity. Hold on.
I just don't think Cammy do
Unless the
it.
meter's not.
I just think he's got
Okay, we got to zoom in a lot. Hold up.
They all said you couldn't do it.
They said I could be in a meters a second.
That's why, yeah. A meter every second is pretty fast. 1 meter every second is pretty quick. Thank you. That's number sense right here, what he's saying. 1 meter every second is pretty quick moving, right? So we should be within under 1 meter per second. I can, but just to be consistent with units, I'll just zoom in. Okay, ready, Cammy? Let me get rid of all these runs. Ready? Okay, don't you do normal for now. If it doesn't work, we'll zoom in further. Focus. Clearly, it's not working too well, guys. Cammy, it's not you. It's the machine. Hold on. How do we change our units? Let's see. Instead of meters, what if we did like centimeters per second, right? Sorry, you're right on. There we go. All right. Let's see what happens now. All right, let's try it one more time. Now, I did 0.001 meters, which are millimeters per second. So we might have to go a little bit higher after that. We might have to zoom in further. I might have gone too far. Let's try this. Why is it reading? She's doing a good job. Yeah, you're doing a great job. What about this? Let's see. Let me just do a hand. Okay. Let's just do this for now. Let's discuss what's going on here.
From moving your hand, it's just the tiny ones, like the big spikes are when you move out of the frame.
Out of the frame, yeah. I mean, it's also, if I move quickly back, it's gonna interpret that to be a positive velocity. We're getting this one. Then when I move quickly forward, a negative, then a positive, then a negative. It's just going like this back and forth. It's trying to measure the instantaneous velocity, which is tougher. It doesn't take like an average over a long period of time. Mr. Donison told me, he's like, this one doesn't work too well, you can try it, but clearly it doesn't work well. Alright, let's discuss what we think would happen though. So, as Cammy moved away, thank you, Cammy. As she moved away, so she started by standing still. So what we should have seen is this. We should have seen her standing still first, meaning zero velocity. Then, As she starts to move away, she has what we consider positive velocity because her distance is getting greater. Okay? So you might see like a spike and then like a positive velocity for a while. That would mean positive velocity. Then when she moved away, right, then she would stop. She has, again, no velocity. So what you would see is this. You would see this drop down and then no velocity for a while. Then she starts to walk toward the detector, and that accepts it as negative velocity. So what you will see then is a spike like this. And then if she stopped when she got back to the front, it would look like that. So again, focus people. Stop looking there, look here. Standing still in front of the detector, moves away with a positive velocity, standing still away from the detector, then moving back toward the detector as a negative velocity. Okay, a negative. Now, what you're going to work on, okay, and I'm going to give you a few days, not just one night, because you might have a question. I'm going to tell you now, though, here's the instructions first. If you have any questions, they need to be asked tomorrow. With your lab, I'm telling you now, today is Monday. Next Monday. Today is Monday. Next class is Wednesday. Your lab is going to be due on Thursday. Okay? If you have, you know what, let's take a problem. Your lab is due Friday. If you have questions, I want questions on Wednesday, not on Thursday.
Okay.
So write that down again. You look at it tonight and tomorrow night. Any questions you can ask me on Wednesday, it is due on Friday. I do not want to be getting emails Thursday night. Too many people have been doing that lately. Until the last minute. You're working with one other person. So each group sends up a representative. Decide who you want to work with one other person, set them up.